Hello. So we think that we have a few people, so it'd be good like if you could come in the front. There's nothing to be afraid of. In fact, I have got some small gifts for you. So it's better if you come front, please. Okay, should I start? Okay. So today's topic is the importance of SSHFP and how to configure SSHFP for network devices. So has anyone ever come through this term SSHFP? Never heard of it? Sorry? Oh, okay. Okay, but I can tell you that if you are a network engineer and ever have tried to log in to a Unix host or Linux host or Cisco router, you have definitely come up with a picture like this, right? So does anyone know like what does it say? I've got lots of gifts for you. Yeah, but what is the meaning of this message? Yep. So I'll just talk a brief introduction about SSH, like how does it work? It works over a public key infrastructure. Like it has got two different keys, one public key and one private key. So this message is trying to tell us that when we are trying to log in into a Linux or Unix host or a Cisco router, anything that is running in SSHTP service, so it's trying to say us that we are connecting to a new router or new host, and the fingerprint of the SSH key is this. So do you trust this or not? Have anyone ever tried to completely read it out? Ever? No. Okay. And maybe people who are using Linux or Unix system servers maintaining, they might have come through this sort of a message. No matching host key fingerprint found in DNS. Are you sure you want to continue connecting? Yes or no? So in most of the cases, we just say yes, and we just try to log into the router. So what is the problem with this? Anyone? Yeah, like actually, we are not getting into the real fingerprint, and we are not checking the real fingerprint ever, and we are just blindly logging into the router or into the server or whatever it is, and in most of the cases, we might be victim of man-in-the-middle attack. Does anyone have any idea about man-in-the-middle attack? So normally what happens is like in the newer Unix or Linux systems, we have got ECDSA encryption, but in the previous earlier days, we used to have RSA, SHA, then DES, 3DES, and so many encryption algorithm running. So a little history about SSHFP. Like SSHFP, it first came in 2006, It was defined in RFC 4255. It creates a DNS record of type SSHFP. SSHFP actually stands for SSH fingerprint. So what happens is like it is distributed by DNS and verified by DNS lookup and more likely secured by DNSSEC validation. Does anyone have ever heard the term DNSSEC? Okay. That's good. So anyone running a domain on validated by DNS? Oh, okay. Okay. The DNSSEC helps us the same way, like adding a verification for a valid DNS lookup. So in previous, how we used to check through this? Like, has anyone ever checked their home folder for a Linux or Unix system? There is a folder .ssh which is most probably hidden and always hidden. Has anyone ever gone through the contents of the folder and files? Never? Okay. So what happens is like there is always a file called known host file. So when you are logging into a new host and you don't have the fingerprint of the SSH fingerprint of the host, so what it tries to do is it tries to add a new line containing the SSH key of that public key of the host. So people used to verify once and distribute this known host file among everyone. So like let's say that I have got 1,000 POPs in different country, and I don't know, it might be that someone is going to a POP and replacing a router. So we have to update the known host file and we have to redistribute the file with everyone who has access to all the routers or network engineers who need to log into those routers, right? So do you think it is scalable, like creating a known host file and sharing it among everyone? Like the old days of DNS when there was only one file which was host file which was being shared with the Linux distribution or Unix distribution, the operating system distribution. So do you think like it's feasible? It's not feasible. Plus, there is a chance that someone can easily modify it. Like if there is an angry employee who wants to put us into a different place, like with running a honeypot and trying to grab our passwords. So someone can easily change or add a new fingerprint and distribute that file. Or maybe use a Bastion host. Does anyone know like what is a Bastion host? However, I will give you one and one, okay, but I'm not going to give you all of my gifts. Okay, prior to that, like anyone has any experience about running a Unix or Linux host? Never? Because like let's say when you are running or working as a network engineer, it's probably best idea to use some sort of Linux or Unix host for yourself, in fact including laptop at your home, and even so, because at a certain time it will be very much handy for you. So this is a known host file. This is just one line of a known host file. So what does it contain? The first word is actually the host name, or in some cases the IP address. Then this is the algorithm, ECDSA, SHA-2 and NIST P256 encryption algorithm. And the later part is actually the public key of the host pdr.bofh.network. So why do we need SSH FP or SSH fingerprint? Okay, now I will go back to basics of DNS. Can anyone tell me like what is the maximum answer size of a DNS server in terms of packet size? Okay, I will get into it while we are doing the lab. So how the fingerprinting is done? The fingerprinting is done via an encoding at first. The encoding is called base64, and then we create a SHA-1 and SHA-256 checksum of the base64 encoded string of the fingerprint. So before running into generating the fingerprints, what do we need? We need fingerprints of the host. There must be a proper SSH/FP DNS record. You must have a DNSSEC signed zone. Besides that, you must have a DNSSEC validating DNS server or LDNS support in your SSH client, and a SSH client capable to verify DNSSEC validated fingerprint. Most of the modern operating system, I am not sure about Windows, actually supports DNSSEC validated fingerprints in the SSH client. So what it is like the fingerprints of the host. So this is how we can generate the fingerprints in the host. We have to run it in the host. For the host, we are trying to generate the SSH/FP records. So we have got 1, 2, 3, 4, 5, 6, 7, 8. Can anyone tell me like why we have got 8 records, SSH/FP records? Can you see any similarities in the records? One, two, three, four. Can you check the 5th field? This is the 5th field, okay? Okay. So what is the details of a fingerprint? At first it is the host name. pdr.boph.network is the host name. Record class is internet. In the early days, actually, in DNS, we used to have more classes. I forgot the name of the network. But nowadays, we just have internet. Then we have the record type, that is SSH/FP. Then we have got algorithms, encryption algorithms running. So if it is 1, then it is RSA, for 2 it is DSA, for 3 it is ECDSA, and for 4 it is ED25519. So these 2 records are for ED 25519. The 3, that is for ECDSA, for the 2 it is DSA, and for 1 it is RSA. For each of the algorithms, we have got 2 types of fingerprints. One is SHA-1 fingerprint, and the other is SHA-256 fingerprint, and the key. And the original fingerprint of the public key of our SSH server of the host we are running. So if you are running a most modern operating system, it will generate all 4 encryption algorithm, but old ones only might generate RSA and DSA type, not other type of algorithms, because ECDSA and ED25519 are the modern cryptographic algorithms, which was most likely added in RFC 7479. And for support of ECDSA and ED25519, we must be running OpenSSH server with a version of greater than or is equal to 6.7. So how are we going to distribute it via DNS? So we have already got the fingerprints in place. So now what we are going to do is we are just going to check that whether if those records are available in the DNS. So we are using the command drill minus capital D stands for DNSSEC validation. Then the host name, that is pdr.bofh.network, and record type, which is SSHFP. And we also have DNSSEC validated record, the RRSIG. Can anyone see that? I know it's a bit small, but you will get the paper. You can get the paper downloaded from Appnext website, I think 1 or 2 days later. Actually, I will show you in live demonstration just after some time. So how can we validate SSH fingerprint with SSH client? At first, we have to check that whether if we have support for LDNS in our SSH client. So how we can do that? We can run a command called link LDD, and if we find out that our SSH client have a library linked libprivate LDNS SO, then that means that it has the support, necessary support for running SSH-FP validation. If your SSH client supports LDNS, then we have to maintain a trust anchor. We have to run unbound anchor. Then we have to run our, don't think too much about this part because I'm going to show you in live configuration like how to do that. And if time permits, I will allow you to also log in to one of my server and check these things. So we have to add the trust anchor key for validation. Does anyone know like what is the trust anchor key or the root key for the DNS? Have anyone ever heard the term like key rollover by IANA or by ICANN in the root zone? Yeah. So for DNSSEC validation, we must have that key in our caching recursive resolver. Otherwise, it cannot complete the full chain of trust. So if you are running a BSD-based system, you have to put the root.key file in etc unbound folder, and if you are running some sort of a Linux variant, especially Ubuntu or Debian, you have to put it inside var lib unbound directory. So that part is like if you have LDNS support in built in with your SSH client, but what if your SSH client does not have the support for that? In that case, you have to run a validating resolver like Unbound. Have anyone ever heard the name of Unbound? It's a very lightweight recursive DNS server. It's not like Bind, with which you have worked out, because Bind serves both as an authoritative server and a caching recursive server. But an organization called NLNet Labs, they have compartmentalized the whole DNS service application into different component. Like if you just want to run an authoritative server, you can use NSD. If you just want to run a caching only server, you can use Unbound. And if you need DNSSEC validation, then you can use OpenDNSSEC for automatic key rollover and everything. So here is a small test, like if we want to test like SSH root@pdr.bofh.network, the authenticity of host can be established. The ECDSA key fingerprint is like the following. Are you sure want to continue connecting? Yes, no. So what I have decided to just terminate it with Control C, that I do not want to add it to our known host file, so that I can show you the rest of it. So the next time I have just tried to log in into the same host with an option called verify host DNS key yes. Most of the modern Linux system has this option enabled by default for the SSH client. If not, you can modify the SSH_config file in your home directory or in globally. So what happens is, like, it will not ask for the for a question like the adding the fingerprint in the known host file. It will automatically log me in. Actually, automatically log me in because I have SSH private and public key authentication mechanism activated. Otherwise, it will prompt you for a username and password. So the test actually runs properly, right? The DNSSEC validation properly works. SSH login without .known host works perfectly, and I'll just show you that the known host file will be blank. There will be no added record for the host. So what is SSH and SSHFP in more elaborative way? SSH creates a public and private key pairs. So for Linux or Unix-like system, under etc SSH folder, you will have files like SSH_host_ different type of algorithms. If anyone have access to a Linux or Unix server, you can log in and you can check it, like just with the ls command. And normally you will have for the same algorithm, you will have two keys. One is the private key and one is the public key ending with a .pub. These files are normally generated when the first time SSH service is run. And this part is actually automatic and hidden. Sometimes you might see it, like, have anyone ever seen like booting Linux host, and sometimes there is a small text-based graphic in the left corner? Has anyone ever seen? Yeah, little ASCII art, yeah. Yeah, actually that is the part which happens behind the scene, and which we do not most likely try to give our mind to. So what does SSH keygen does? It generates the fingerprints for those keys. Okay, so far it's very much easy for a Linux or Unix host. But what if we want to do it for a router? A router do not come with a lots of SSH-based subset application built with it. Like, let's say a Cisco router. I think Juniper supports, because Juniper comes with the FreeBSD based operating system. Then Nortel router, no, they do not support. So what if you want to create these fingerprints for a Cisco router? How can you do it? Because the routers do not have a SSH keygen command. Any ideas? Okay, let's see. We will try to configure a router and try to log in the router without too much configuration. So Here is our router configuration. It's very much easy. Like we have to give the command IP domain name. So my domain name is bofh.network for my network, for all of my hosts and devices. Then we give the command crypto key generate RSA modulus. So if you want 4096 bit then encryption, then you should give the modulus as 4096. You can give lower than that, but you cannot give higher than that. The higher it is, the better it is. But do not please give lesser than 768 bits. Any idea why? Because if you give encryption size less than 768, what will happen is like it will only support dash encryption or 3 dash encryption, which has been literally cracked by so many people around the globe for so many times, although it was a US standard. So try to do something more than 768 bits up to 4096 bits. So how can you extract the public key from a Cisco device? Because in Linux you have got the folders, you have got the files, you can copy and paste the file, but how can you do it for a Cisco router? Any ideas? Preferably, you have to directly connect to the router point to point via LAN. Then you have to use the command show IP SSH. You can copy the string starting with SSH RSA and ending till the last line. For remote connection, add the key with the prompt, like when it is asking, do you want to add it or no, yes or no, and verify the keys. Definitely verify the keys, because there and mostly what happens is like when we are trying to verifying a web certificate or this sort of certificate fingerprints, what we try to do is we try to match the first 4 characters and the last 4 characters. But there have been applications which can generate similar alike fingerprints, which can generate certificates with similar alike fingerprints. Like the starting 4 characters and the ending 4 characters will always be the same, but the middle characters will be different fingerprint. So let's save the file in a Linux or Unix host with a file name like hostname _RSA _ key.pub. Then this is a very small script. It is written in Bash. It is named as sshfpgen. So what it does is, actually we know that what the algorithms use to generate the fingerprint. So what we are trying to do is gathering the public key. We are manually trying to generate the commands rather than the SSH keygen command. This actually does the same thing what the SSH keygen command does, except as we are generating for Cisco devices, we do not need all the algorithms. We just need RSA algorithm. So we are trying to generate only type 1 SSHFP record with the SHA-1 and SHA-256 fingerprint. So let's say if we are going to run it for sshfpgen r1.bofh network, we will have 2 lines output like this. So we have to put it in our DNS system, and we have to reassign our zone file, and we have to update our DNS. We have to wait a little bit to so that our DNS records can get propagated along the DNS servers. Then we can query our DNS server, dig SSHFP, just to make it smaller, very smaller. So same records are added in our DNS server. Now let's try to do connectivity test. So if we are connecting without a DNSSEC validation, we will be again asked like that, are you sure you want to continue connecting? And if we are doing it with ADNSX validation, we'll be prompted for our username rather than adding it to the known host file, and no records will be added in the .known host file. So I will jump into some live demonstration, but would someone like to make your hands dirty? No one? Okay, so like, is it okay like if I give you an access to a Cisco router? You can configure it, then you can copy, paste the keys, and you can generate the SP records. That's all. Okay. Can I have your email? can try to log in to the router. Minus I, and you have to download the C and use it with click minus I. Yep. So these are the task info files. I'm using my Unbound setup, and so so this is the line actually, which in a single word enables or disables genetic validation using my DNS server. Okay. So right now I have it disabled. You can see this comment out. Disabled. Let's see. My DNS server is 127.0.0.1, that is local DNS server, and options EDNS 0. Does anyone have an idea of what is options EDNS 0 or this point or options EDNS 0? Can you explain query genetic validation answer without using options EDNS 0? So who am I? I am root. So let's go to my home directory, which is /root. So I have got a folder named .ssh. It has got right now it has got 4 files. This is my GitHub key, and this is a known host file. So the file is blank, right? Is there anything in the file? There's nothing. The file is blank. Okay. Okay, yes, of course. Displaying this, I'll just come to here. So I am trying to log in to SSH. So this is actually a router running in AWS or Amazon Web Service. I'm trying to log in. It's asking me that authenticity of host cannot be established, and this is the fingerprint. Would you like to continue connecting? Okay, I'll say no, I will not connect. So it says that the host key verification has failed, right? Okay, let's see if it has added anything in the host file. Nothing added. So this time I will say, yes, connect. So this is my router. Just in case you are not sure, this is the Trios XP PLV 1000. So I am going to exit and I am going to show you the contents of node host. This is the public key that has been added, and the fingerprint it was talking about is the fingerprint of this string. Okay? So, let's check. Anything in the file? Nothing in the file, right? So, if I try to connect again, it will prompt me like that. So, once connected, and it is in the file, it will never ask me or prompt me like this, okay? So, let's connect again. It's not prompting me for that, for this thing. Do you want to connect? Continue? Yes, no? Right? Okay. So, let's exit. File is blank, right? So I am going to enable DNS stage validation for my resolver. Okay. I have not yet enabled, okay, I have not yet restarted the service, so DNS stage validation is not yet there. It will show the record, but it will not be DNS stage validated. So service, unbound, okay. So, the file is blank, right? It has logged in without prompting me, like whether if the fingerprint is valid or not, whether if I want to add it to my node file or not. Because right now what it is doing, it is validating the fingerprint from my DNS record, from my SSHSP DNS record from DNS server. So just to be sure, the file is still blank. So this is actually the main purpose of SSHSP. So the point is like why is it important for routers and network devices, right? Because you are running like thousands of routers. You never know that if someone has changed their router with a different operating system or different something, and just to or running a honeypot or something like that to uh, grab your passwords and everything. So the question is how you can generate the public key from Cisco routers, right? So we log in. Uh, Here is our public key, right? Can anyone see it? Is it same like this one? This part? Sorry. Okay, like this is starts with quad A, 97 FAD. This is starts with quad A. Here is the 97 FAD. So you can get the public key. I think accidentally I copied and pasted something. So how does the SSHTTP record look like? So these are of my SSHTTP records. We have as the router running Cisco, so we have got only RSA and we have got two different type of algorithms, SSH1 and SSH256. So any question, any comments so far? I'm going to send you this. Uh, I'm just going to give you a small bash script, which is was it interesting? different. Because like here it is like the fingerprint is Wi-Fi based, right? 256 moments. It's from 935. Okay, just a minute. Let's see. That's very weird. format.